All right, so I mentioned CFCs. Actually, we are here. We went through contributors, we went through reaction, and I just want to touch on this reaction, okay? When you do your presentations in class, you do not have to worry about anything other than CFCs. That's really the only thing you have to know about ozone depletion. But I fear that this is so new and it's such a common gas in the atmosphere that we have to definitely look into it, and I don't know what's going to happen with this. So you have nitrous oxide that gets in the atmosphere through the burning of fossil fuels and industrialization of agriculture, excess fertilizers. Once it's in the atmosphere, somehow, because it's a persistent gas, it travels through the troposphere and makes it to the stratosphere. When it's in the stratosphere, it reacts with an oxygen and it forms nitric oxide, which is what's going to contribute to ozone depletion. So like CFCs, UV rays, somehow CFC makes it through the troposphere, hits the stratosphere, and it only reacts with UV rays, and then that chlorine causes the damage. The same thing happens with the nitrogen, okay, or the nitrous oxide and then the nitric oxide. Then that reacts with ozone, depleting the ozone. So step 2 would be the depletion of ozone. And like CFCs, step 3 produces that compound again, which will go and deplete more ozone. So it's a vicious cycle like CFCs. So it's definitely something we have to be concerned with, because we can't ban nitrous oxides from making it into the atmosphere. We could definitely reevaluate the way we burn fossil fuels and the way we farm to try to reduce less, but nitrous oxide is a naturally occurring cycling of matter, so it's going to be a little hard. All right, I want you to also know the following. We've discussed that weather occurs in the troposphere, so clouds are in the troposphere, but in the stratosphere, we have clouds. They're called polar stratospheric clouds. Sometimes they reference them as PSC. So if you see that word, I want you to remember that those are clouds in the stratosphere, and they actually help make ozone depletion reaction happen faster. So it contributes to more depletion or faster depletion, I would say. The picture of them? I don't really know. But let's say yes. All right, you don't have to know the years, but I want you to know that something really strange is happening. So since the 80s, we knew there was a hole in the ozone, and the hole started in Antarctica, okay? And it wasn't until recently that we have now a new hole, and it's in the Arctic. So now they're kind of freaking out because they've done a lot since 1989 to prevent the hole from continuing to open. And when I say hole in the ozone, I want you to envision, we have ozone molecules all across the stratosphere. Think of them as like a layer of gas, right? They just make up the stratosphere. They're not there. So that's what it means by hole. The concentration of ozone molecules is not in the stratosphere at the levels they should be. And you'll see a lot of diagrams that describe holes.
Why is there a hole in its highest concentration is just outside?
Okay, so highest concentration outside the hole means that area is highly concentrated with ozone. Anywhere there's a hole, the concentration is not high.
Right. But wouldn't you think it would be
So their measurement of how much ozone is in our atmosphere varies, okay? When there's a hole, there's less concentration of ozone. It is seasonal. Please write that down in your notes. A lot of this information that I have coming up will show you things like that. Like these graphs, holes in the ozone appear during certain times of the year, and then they close back up. So a lot of people thought when the hole first opened, oh, it's a hoax. You could look up articles. There was a lot of articles about the ozone hole is a hoax. We don't have to ban CFCs. What are they talking about? And the following year comes and the hole's bigger. And that's what they saw, was a constant pattern of the hole opening and closing, but every year it was a bigger and bigger and bigger hole. And there's a lot of graphs or maps of the or globes with concentration of ozone where you'll see it's getting less and less and less, and you see the weakened concentration. Record-breaking depth of the hole. Does this have a year on it? No. 2006. So just recently, 10 years ago. All right, we could skip that. Something really important, like global warming or greenhouse effect has Kyoto Protocol. Ozone has Montreal Protocol. So this happened in the U.S. The U.S. banned emissions of CFCs. For us to take that kind of measure, we knew there was a serious problem, and because it rarely happens. We know global warming. Everybody knows it's there, and we haven't stopped, right? Emissions, I showed you that. But this, in 1989, they said no more, and look at the reduction of concentration of CFCs in the atmosphere because of that. Or the concentration of emission reduction, I should say, not how much is in the atmosphere. So know that the Montreal Protocol is linked to banning of CFCs and in efforts to assist in regenerating the ozone concentration in the atmosphere. So a lot of you ask, what exactly is ozone depletion? What exactly is the problem? UV rays come down from the sun. You know that because of the greenhouse effect, hopefully. When they come down, that's ultraviolet radiation. Radiation can cause a lot of damage to cells, tissues, single-celled organisms, to us in minute ways, but then more concerning ways. What ozone does is it prevents direct levels of UV radiation from hitting Earth. Without that layer, you have less protection, okay? So it blocks direct UV radiation from hitting Earth. What are the effects that we are seeing currently because of this whole or lack of concentration of ozone in the stratosphere? Some environmental effects. We're going to definitely see damages to marine life, especially our producers of the world, which is plankton. They are single-celled organisms. They're going to be affected by ultraviolet radiation. It's going to destroy crops. For us, we could go as simple as sunburns to skin cancer, which if you Googled, I should probably add that to my slides, the levels of increase of skin cancer over the years, you'd be very surprised. Anybody know what that is? Well, cataracts, right? Which are very highly linked to diabetes, but now because of the whole. And then, like any radiation, when you have chemotherapy, that's radiation, right, in your body. Your immune system is shot during that treatment, and you feel terrible. Same thing happens with excess ultraviolet rays coming down. I wouldn't say excess. I would mean strength of ultraviolet rays coming down.